In this video, we'll learn about the natural greenhouse effect. We will see how our atmosphere helps to keep our planet warm by making it harder for the energy we get from the sun to escape back to the universe. The second part of this video will deal with the way humanity is changing the atmosphere, causing climate change. In this first part, we examine the natural state of our atmosphere before humanity began to change it. If you pump air into a football, will that make it lighter? Well, the answer is that the football will weigh a bit more. This is because gases, like oxygen and nitrogen in the air, are made of atoms which have mass and are attracted to the Earth by gravitational force. So as you add more and more molecules, you add more and more to the weight. The important idea is that our atmosphere is held to the Earth by the force of gravity. In fact, it is just like the oceans, an ocean of air, except, first of all, it is 1,000 times more spread out than water, and secondly, it gets more spread out the further away from the Earth you get. Gases are heavy, but not very heavy, and they're made of real matter. Let's now look at the energy we get from the sun. You probably know something about the electromagnetic spectrum, rays of energy that travel at the speed of light. Here is the full spectrum, starting with the low energy, least harmful radio waves, and finally the more harmful rays, ultraviolet, X-rays, and gamma rays. Most of the energy we get from the sun comes to us as visible light. Most of the small amount of ultraviolet is trapped in the upper atmosphere by ozone, and there's a linked video for you to see on that, although enough gets through to damage our skin if we stand too long in the sun. And we only get a little of our solar energy from infrared or heat radiation. The visible light gets straight through our transparent atmosphere and is partly absorbed by the Earth, which gets hot. Now, hot things radiate infrared rays. You could try holding your hand very close but not touching your cheek. Can you feel a glow? That's the infrared radiation. Infrared cameras can pick up this radiation emitted from warm bodies. Now, here's the catch. Although visible light got through the atmosphere, the infrared radiation coming from the Earth finds it more difficult to get through. A greenhouse, or even a car left in the sun, works in a similar way. Visible light gets through the glass, heats the soil or the seats, which glow, giving off infrared heat radiation. But this cannot get through the glass, so the heat builds up inside the greenhouse and the car. So the atmosphere acts a bit like glass, letting visible light through to warm the Earth, but some of the heat or infrared radiation now given off gets absorbed by certain gases in the atmosphere, and these are the gases we call greenhouse gases. In this way, the Earth is kept warm, and we say there is a natural greenhouse effect. The two natural gases that absorb infrared are water vapor and carbon dioxide. If you live in the colder climates, you will know that clouds, made of water droplets, insulate night skies in the winter, keeping you free of morning frost. But without the clouds, the heat gets away and the frost forms. Before the world became industrialized by burning fossil fuels such as coal, oil, and natural gas, the carbon dioxide concentration in the atmosphere was about 0.028%, tiny compared with oxygen at 21% and nitrogen at 78%, but enough to keep us warm. Without this natural blanket of insulating gas, the Earth would be too cold to support life as we know it. So to summarize, we learnt that the atmosphere is made of gases held to the Earth by gravity. The atmosphere lets sunlight through to heat the Earth, but the heat radiation then given off is partly absorbed by the so-called greenhouse gases like carbon dioxide. This is a good thing and keeps the Earth warm enough for life to exist. In the next video, we'll see how burning fossil fuel adds carbon dioxide to the atmosphere and how this effect is causing global warming and climate change.